Awesome. We should be good to go here. So, generically, what I'm hoping to do is put a very contextual application to augmented reality for us as geospatial professionals, but specifically to those applications where we're talking about right-of-way asset management, both in terms of pre and post construction, so both in the as-built and the design visualization, and how augmented reality can really enhance our experience there. But before we can jump into any of that stuff, I wanted to first kind of touch on what the mixed reality spectrum really is, and then we'll jump into some of the user experiences, use cases. And then I'll also talk, hopefully in a sufficiently generic enough fashion, about the performance and system hardware, some limitations of augmented reality, and then of course the none of this works really without good quality data. So there are some considerations for data there as well, and then we'll end up with hopefully some time for some questions as well. When we're talking about this mixed reality spectrum, and Gavin in the intro there did a great job of illustrating that we don't just talk about reality and augmented reality. It actually is a full spectrum from reality to virtual reality, where augmented reality is really defined generally by enhancing your environment with digital content. So overlaying digital content on the real world. Where further down the spectrum, augmented virtuality, or something like the device you see here, which is the Trimble XR10, which is based on the Microsoft HoloLens, which really then takes just overlaying data to your physical environment to the next level, and allows you to interact with both the physical and digital environments together. And then fully on the right side of the spectrum is the virtual reality, where your physical reality is completely replaced with digital content. So what we'll be focusing on today is specifically the augmented reality, where we're really taking a view of the real world and overlaying digital content that enhances our experience in that realm. I'm also going to do my best here to not make this a sales presentation, but I have a lot of contextual examples here that you'll see screenshots from our software, and I wanted to give you just a quick overview of what it is that Trimble uses as our platform for augmented reality, delivering augmented reality experiences to our customers. It's a product called Trimble Sight Vision. It is designed for high accuracy outdoor visualization using GNSS as an augment to that, to allow a georeference model to be automatically placed and very accurately placed into the real world. With the main goal to be able to deliver very complex information in a highly accurate and an easily digestible, easy to understand fashion. In addition, it's on top of just seeing the digital content over the top of the real world. There's a lot of value in including the very rich attribution. The information about the models is also accessible through something like Trimble Sight Vision. Another thing that Sight Vision and augmented reality does for the user is that it allows the user to move around in physical space and view data from any perspective, from inside, from on top, from underneath. All different perspectives are then available to the user. So when I reference Trimble Sight Vision or augmented reality, this is the product that I'd be talking about. So what I'd like to jump into now are some use cases and user experiences and some data that we've been working with, and some of our customers have provided to us, just to give you an idea and to jog your imagination about how this might be used in your contexts. In terms of asset management, specifically in the right of way, but again, it kind of transcends just the right-of-way asset management. This is truly a technology that spans the spectrum of data use. But we find that augmented reality fits into one of four major buckets of focus. The first is the pre-construction visualization, and I'm going to step through each of these individually. The post-construction visualization, the need to see things that you can't see. So visualize hidden infrastructure. Maybe it's buried underground. Maybe it's obstructed by something else in the physical world, so that you can't see it. And then finally, to kind of overlay additional valuable contextual data on top of the real world that might help complete the picture of the entire site. So when we're talking about the pre-construction visualization, we think about things like visualizing design, what a proposed design for an intersection looks like, rather than having to imagine that in the office from a 2D plan, or maybe even from a high-quality 3D image. The user is still left to formulate what that looks like in the real-world context in his mind and in their imagination. And what we want to do is bring that out into the real world, so we can visualize those designs in the spaces where those designs will actually be constructed. In addition, you can quickly and easily cycle through multiple design options or iterations, which enable the users to quickly react and provide feedback based on the real world context in a way that they wouldn't be able to do otherwise. Another thing, especially in the pre-construction phase, is it becomes very, very obvious where there are site building equipment, or there's an obvious obstruction with a building, or there is something that wasn't captured in the pre-engineering phase. All of those things can be enhanced by the use of augmented reality where you're standing in the real world. The final bullet point there is massively important and changes the face of public and stakeholder engagement. The ability to communicate what a design will look like gives a whole new meaning toward to something like a virtual town hall, or a town hall meeting, where instead of visualizing on a PowerPoint up in front of the room, you could actually take those constituents out to the real world and visualize those plans. Some of the things that we're seeing here is, from the top right, is the idea of standing at the site and visualizing what the new construction, or the final construction of a new bridge and road alignment will look like over the course of the project's life. So being able to stand there and visualize this information gives the viewer a great context. And down on the bottom left, it can be as simple as new infrastructure, like signals or bus stops or signage. Those sorts of things can be visualized in the real world, in their context, to make sure that, for instance, maybe the new sign will obstruct the visibility of the mobile gas station sign, and that user might or that constituent might have some feedback or ask for a remedy in some way, but they may not know that otherwise. So pre-construction visualization is a huge use case for the augmented reality world. Here's another one, not necessarily a kind of a right of, well, it is a right of way, but here's what the construction of a new high tension power lines would look like through a particular location. So you can see what what views it obstructs, and are the materials conducive to all of those pieces of data are enhanced by the fact that they're put into the real world and given in the real world context. I think one of the most exciting applications for AR technology is in the post-construction, or at least in the during construction phase of a project, where you'd like to evaluate progress against the plan. So the construction inspection process can be greatly enhanced by the inspector's ability to see what needs to be, or what is intended to be constructed, and what's actually been constructed. You can also verify for the construction inspection, get a very good idea about where in the process the project actually is. So the completion status or update status is a great thing. This is one of my favorite examples, and it came about by accident. This is actually the site of our Trimble Dimensions user conference. We have an off-site construction process where you can visualize and actually interact with all of our machines and whatnot. And you can see that the design right away comes from the bottom right across to the top left, when in fact the road has been cut kind of from the bottom left straight through. The users, our team using sight vision here, thought that there was a problem with how the road alignment was actually laid out in the field by the contractors. So by accident, Trimble Sight Vision was used to identify a discrepancy with what was intended to be constructed and what was actually constructed. And without seeing this, it might have been much further down the line when that was actually discovered. But other things like utility installations, you can see the actual installation versus what's been intended, again, in a very easily digestible, highly contextual fashion. And it can be as complex as you'd like. So, you know, it's kind of a busy picture here, but as you walk through there, you can see very clearly the digital design over the top of what's actually been installed, and verify that girders are installed where they should be, and that you know, everything that has been put in is as intended. You can take data from all types of sources, imagery, LiDAR, whatnot, and use sight vision as a visualization tool for that. So we can capture this information. Augmented reality is a way for us to put that data to work for us. Overlaying cut fill in a context like you see here is a fantastic way to gain quick, easily digestible status about a big chunk of work needs to be undertaken. Visualizing hidden infrastructure is another, I think, another really exciting place where augmented reality technology really fits here. You know, visualizing things that you can't see, like buried utilities or other buried infrastructure, or those assets that you just simply can't see. They're obstructed by one thing or another. Here's a quick view of. In sight vision, we have a feature we call pit view, which allows you to open up a pit and look down into it and see what utilities are down there. Being able to visualize this in the context of a construction project, or either in the pre-construction, during construction, post-construction phases, gives you a great insight about the very depths of buried utilities, the proximity to buried utilities, to other potential hazards or other project activities. So a fantastic way to visualize things that you can't see. And on the ground, obviously, all we see is our manholes and valve covers. and maybe some other innate clues. But if the data is available, the hidden infrastructure becomes visible and an invaluable component of the decision-making process. In addition to just visualizing the hidden infrastructure, and I hinted to this before, where attribution is a massive component of what sight vision and augmented reality is capable of. So not only visualizing it, but identifying what it is and gathering the information and displaying it to the user for even greater understanding about what's there. And additionally, augmented reality again can kind of take that and overlay it into the real world for decision-making process. So things like you want to visualize boundaries, whether it's right-of-way boundaries, easements, site boundaries, maybe it's flood levels. It could be anything at all. Potential hazards, and even one great use of augmented reality, especially in the GIS world, is quickly and easily determine whether or not your database actually matches what's in the real world. So just a quick review of database integrity can be provided to you by the use of augmented reality. Things like property boundaries can be overlaid onto a site in a way that you don't have to imagine where one pin is and the other and the line between them. You can actually visualize that over the top of a project site. And visualizing database integrity is another thing here. So if a blue dot in your GIS on the augmented reality represents the hydrant, and it's not overlaid with the physical hydrant that's in the real world, you've got some sort of discrepancy, and maybe your data needs to be adjusted or verified or manipulated in some way in order for that data to be even more valuable to the decision-making process in the future. So augmented reality will be a great way to show when your data is really good, and also to show when your data is really bad. And I'll talk a little bit more about the data considerations here as we move forward, but now's a good time to kind of jump into kind of the performance, what goes into making augmented reality work, and some of the limitations thereof. Augmented reality technology works on the premise of motion tracking. So on startup, the device establishes a local coordinate system using visually distinct features in the view. And then as that view changes, it uses those visually distinct features to track motion. That visual information, as well as sensor information like the gyroscope and the accelerometer, are used to estimate the position, which is known as the position and orientation of the device in the real world is known as the pose. And the pose, that basic pose, can be enhanced with something like what Sight Vision uses. We take a high accuracy GNSS and relate that pose to an actual physical location on the Earth, and therefore we tie the camera's pose to the real pose where you are in the real world. And what this really means is that you need a good high quality GNSS position, and you also need visually distinct features in the camera's field of view. And in those cases where you don't have visually distinct features, or the camera can't make those things out, like there's the lack of identifiable objects in the view, meaning you're looking at a single gray wall, or you're looking up at the sky where it's all blue. Or down at the grass where it's all very, what appears to the camera and the technology to be very uniform features. So there are some of those limitations to augmented reality. Low light, meaning augmented reality is not great at night, but the performance does vary with the device available, or the camera available in the device. these kinds of limitations with a lack of identifiable objects, low lights, can cause the view of the data, the overlaid data, to jump around, and the providers, something like Trimble Sight Vision, tries to do its best to orient the data, even with the absence of some of these features, using the GNSS position as well as heading, as long as you're moving, and it allows the data to continuously be redrawn appropriately. So working together, these things are they make the augmented reality solution an experience much better. Different devices have different cameras, and those different cameras have different capabilities, especially as it relates to the drawing of data further away from the user. So just a couple of comparisons here from the Samsung Galaxy S8 Plus, where further from the user, you can see that the data kind of tails off from the edges of the pavement. But something like the Galaxy S9 or the Google Pixel 2 do a little bit better job of maintaining the continuity, both close to the user and further away. But most cameras do work relatively well with data presented at a fairly short range. System components, the general system components of an augmented reality system are right now, speaking specifically about a Google platform, Google provides a set of tools known as AR Core, and they are available on a certain subset of phones that are certified to work with AR Core. So as far as hardware goes, you need an AR capable phone. For Trimble Sight Vision, you need not only that, but also the GNSS antenna, and then something to mount it all on so that it's easily portable and usable. In this case, we provide a wand that has a battery in it, and it all mounts together. So it's a single-handed operation in terms of Trimble Sight Vision. On top of the hardware, of course, you need an application. So something like Trimble Sight Vision. The data to Sight Vision needs to be provided by something. That something in the Trimble case is our cloud application called Trimble Connect, which is kind of the go-between between the 3D model and the delivery of that 3D model to the field. And then for Trimble Sight Vision specifically, GNSS correction services to make the position that's used as highly accurate as possible, so that a highly accurate georeferenced 3D model will be placed very accurately relative to the user's location, creating a good, excellent user experience out in the field. And I kind of hinted before that a lot of this stuff is all great, except for you've got to make sure that your data support will translate to a good user experience with augmented reality in the field. Here's an example of the underground utilities, where what's in your GIS or what's in the design is likely a 2D line, which has vertices, and it might have some attributes. But how do you translate those attributes into a way that makes the visualized 3D model into something that is digestible by the user? So in this case, we take, in the case of Sight Vision, we take the attributes of that feature and translate them into the 3D model themselves. So we recognize the word pipe, for instance, and we draw a circular pipe as opposed to a square pipe. The diameter is then used to scale the pipe so that the pipe appears 36 inches across, when in fact it is 36 inches across, and the one next to it is only 6 inches across. And then the depth, of course, is another attribute that may or may not be available in many data sets. Another big challenge there is that that data may not, your data may be horizontally accurate, but to visualize underground assets, that depth attribute becomes extremely important. And then, of course, we can have all kinds of other rules, things like gas pipes are represented in blue or water pipes are represented in red. Makes sense that it would be the other way around, but that's the idea here, is that a lot of that data needs to be, a lot of your 2D data needs to be translated into 3D models, and we can do that on the fly with something like Sight Vision. But without that highly rich attribution, much of that is not possible. So if you'd like to use your data for augmented reality purposes, make sure that that the information and the context that you'd like to deliver to the field users is available in that data set. Other things like maybe your data set represents a utility like electric power poles. In your data is just I'd like to represent that northern, eastern, or lat long width in the field is a model of a power pole. So it looks like a power pole and not a dot on the ground. Something like Trimble Sight Vision can take a mapping between a feature type and a SketchUp model or a 3D model that's been created, whether it's in SketchUp or elsewhere, and then stored into what we call the 3D warehouse. And anytime that feature shows up in the augmented reality view, it calls up that model and displays it. So you now have power poles or hydrants or manholes that look like manholes and fire hydrants and power poles to give added context to the augmented reality experience. And of course, data comes from all kinds of different places. We all know this, and many of my colleagues speaking over today and tomorrow will be talking about how to acquire much of this data. And it all does have direct applicability to the use of that data, especially in something like augmented reality. So specifically for subsurface utility engineering, the direct measurement of features underground, whether they're using potholing or directly measuring the invert levels for depth of pipe, depth of cover for oil and gas applications, or they might use indirect measurement of sourcing, things like radio detection or GPR. And we're no strangers to data coming from old plans, data that's been around for a long time that hasn't been field verified. So augmented reality will show both really good data and also really bad data. So it's a fantastic tool for data visualization and for validation of GIS of existing GIS data. Another consideration to make when doing data preparation is that many CAD models, especially of standalone infrastructure, are not always georeferenced. So either those models need to be georeferenced in the office, or the augmented reality solution needs to have the ability to measure or models in the field. So there's two methods there: the pre-georeferenced or the ability to georeference it in the field. And then also, for those of us in the GIS world and the survey world, the consistent use of datums is vitally important to the success of data use in the field, especially for augmented reality. Visualizing a model reference to NAT83, the current realization of NAT83, to a real-time source for GNSS that's referenced to WGS84. Both are accurate, but are not relatively accurate. So data management needs to take into consideration the use of datums. And then finally, I'll talk kind of specifically about the Trimble workflow, but generically, it is the process is about authoring the data that comes into the field that will eventually make its way to the field using Autodesk, Bentley, Esri products, Trimble SketchUp, TBC with survey data, and then that data needs to be sent somewhere for storing and usage. So in our case, the Trimble Connect cloud application, which I mentioned earlier, is our go-between between the authoring tool and the actual use of that data in the field by Sight Vision on the far right there. You can exchange data between those authoring tools and Sight Vision in standard industry formats like Land XML, IFCs, CAD drawings, shape files, even to enhance the augmented or to enhance reality and provide additional context. So to kind of wrap this up, the real reasons why augmented reality are even a part of this conversation is that we believe that augmented reality can significantly reduce project schedules from front end iterations over design to provide mitigation to project risk by identifying obstructions or speeding up the logistics planning process, which ultimately result in the reduced cost to implement a project. The construction inspection process is greatly enhanced by the constant review of what's been constructed, what was designed as to be constructed, and prevent problems from progressing too long and make them much more easily identifiable in the field, which at the end of the day results in improved project quality overall. And then just in general, the augmented reality is all about conveying ideas in a powerful and intuitive way. Visualizing complex data, specifically site plans or 3D models or 2D data in the context of the real world takes the user's requirement for a highly imaginative experience to a real world experience that they can move around in physically, visualize things, and formulate ideas and opinions much more quickly in a much more rich and highly contextual way. And again, finding those problems early through the design versus real world visualization is a massive opportunity for augmented reality, especially as it relates to asset management and design and the construction process. And overall, it's to achieve that level of understanding that is much greater than you would ever get simply because you're there on the site, and that site gives you that context for that data. So with that, I'd like to pass on to you an invitation to reach out to me directly. You can send me an email there, and more data about the Trimble specific processes like Trimble Sight Vision. You can learn more at sightvision.trimble.com. And with that, maybe we can open it up for some questions there, Gavin.
Sure thing. Thanks a lot, Dan. And you made a good point there that one of the when I've talked to firms that have applied various AR for their field folks, the engineers going to the field, actually discovering things that they couldn't really visualize any other way. And actually, one team where they actually deployed multiple devices so that different teams could look at the same features from different vantage points, looking at the same registered model. One project, it was an access ramp for a bridge over a rail that they didn't realize till they got it out there. It wasn't really going to fit very well on the site. So there's been a lot of great comments. Somebody just posted, "This is awesome!" exclamation. So, okay, so a couple of questions. This one might be drilling down a little too much into application specifics, something being used, but April H said, how often would data need to be updated to show any new boundaries? Or I could assume other features.
Yeah, that's a great question, and the answer to that is that it's all about the data source and what the context for that data is. If designs are changing regularly, then the middleware that in the Trimble case, Trimble Connect becomes the live connection to the authoritative data set. And as often as the authoritative data set, wherever that model is, whether it's in a GIS database or if it's a CAD drawing, however often that updates, those updates are then available to that middle stage, the Trimble Connect, and that every time a user calls up that model from the field, they get the latest realization of those models. So whatever the project demands, however often those data are changing, the kind of the back end is really the driver for that, and how often those models are updated in their context.
Okay, thanks, Dan. And we actually had a flood of questions about specifics about the GNSS side of it. And rather than go into all of those, I'll summarize the key ones. Was about formats, but I wanted to let people know that actually for over a week, we've already been in discussion about a potential virtual conference focused on GNSS, because there's going to be a lot of questions like that. And
yeah,
hopefully we can reach out to someone from your team to participate. But a couple of people wanted to know about the formats, what you call the Catalyst, the little add-on antenna with the software-defined receiver, standard formats, CMR, CMR plus, RTCM3, RTCM32, MSM. Pretty much, it can use almost any of those.
It can. It's a fully capable GNSS receiver that's capable of using all the standard industry formats, RTCM 3.x, and it's a multi-constellation receiver as well. So all the standard industry formats as far as correction goes are supported. BRS, single base, are all available. In addition, Trimble also provides both a satellite and IP-based correction service called RTX, which is a proprietary correction system that enhances the position, especially in places where internet connectivity is just simply not possible. So there are plenty of opportunities and options for correction services with Sight Vision and Trimble Catalyst.
Okay, a point I wanted to bring up was about AR is not just visual. There's the interactive. In the case of like the XR, the HoloLens adapted for hard hats for job sites. I got to try that out at Mobile World Conference when your team launched it, and we were doing an activity using the hand motions and voice motions, where we were taking a construction model and manipulating it with our hand gestures. So you didn't go into the XR that much. Maybe you could tell us a little bit about those other features besides just vision.
Sure. Yeah. Something that like Gavin mentioned, the XR10 is a product that I think I showed at in the very first slide there, which is a head-mounted computer that displays augmented reality data over top of the real world, but then goes the next mile and allows you to interact with those models using gestures like pinching and moving and dragging things. So you can actually not just visualize, but interact with that model in a way that allows you to maybe collaborate over a building design that's sitting on top of a table, and a user could pull a wall further, or extend or place trees or that sort of thing in a very interactive sort of way that gives even greater control, not only over the context, but about what you're actually seeing, and gives you the ability to physically interact with it. So it takes that augmented reality and kind of merges it with physical reality by the use of gestures and a greater level of interaction with the data.
Cool. A last minute literally question that just popped in, because we'll have only a minute to answer it. This is from Jeff Z up in Canada, who's works in utilities. He said, when folks notice a discrepancy between the model and the data coming from the GIS and the utility, et cetera, can they make annotations or do markups?
Yeah, great question. I think one of the things that that sets Sight Vision apart is that it's based on a collaboration platform. So being able to recognize those discrepancies, whether it's with the model in the real world or in the construction inspection process, or you'd like to note a user's feedback on a design, Sight Vision gives you the ability to create those annotations in the real world. As augmented reality and the Trimble Sight Vision solution becomes more and more mature, we see this as a data collection tool, as a data validation tool, and a critical component of the feedback loop between what's actually in the field and what's in the data, and the ability to resolve the two using augmented reality. So today it's basic markup and basic collaboration tools, and we see that becoming enhanced in the future.
All right, thanks very much, Dan. That was really cool. And we're going to move on to the next session to stick to the schedule, but we want to hear more in the future. I'm going to share my screen.